Good morning, everyone. Here we are at week number 5. So we're over the midway point in the term. We are headed toward the end of the term. We're on the downhill slope. Let's see what we've got going on this week. All right, so last week you learned about an audience, whoever it is that you're presenting information to, and how important that is and how you target that audience and explain to them thoroughly in a way that they will understand what your topic is. So if you're presenting to a group of kindergarten students versus a group of experts in the field, that would make a huge difference, right? If you're talking to experts, you don't have to explain all your terminology and your jargon because they already know all of that. If you're explaining to a group of 8th graders who are taking a science class, that's a totally different matter. Say, for example, your topic is CRISPR. 8th grade students aren't going to know what that is. If you're presenting to a group of scientists who do the technique CRISPR every single day, you're not going to have to explain that to them. So your audience and how you target that audience is really important, and it's an important consideration for any type of presentation that you're going to make or any paper that you're going to write. So chapter 5, what we have going on this week in your SUMO textbook, is all about biases in science. So what are biases? It's a particular mindset that a person has and expectations that that person has about the work that's going on. So what type of biases are there? The researcher has bias and has an expectation of what's going to happen. Your subjects do. Whoever is sponsoring the work, whether it's a company or, say, a drug company or a governmental agency or whoever it is. So there are biases in science, and we have to take those out if at all possible. You're also going to learn about p-values. So P stands for probability. What's the probability that this thing has occurred that you say is occurring? And we like to look for confidence levels or p-values of around 0.05%. So what that tells you is, if you see that number, that about 5% of the time you expect whatever has happened in your experiment to happen just by chance. The other 95% of the time you expect this to happen because of the phenomenon that you are examining. If you have a p-value of 0.01, that means there's only a 1% chance that this could have happened just at random, but there's a 99% chance that it happened because of the phenomenon that you are looking at and experimenting on. So p-values and confidence levels are absolutely important. You will never find a p-value of 0% though, because that just isn't going to happen. We don't have that much confidence in anything that we do, because there always has to be a way for this to be falsified, whatever this is that you're studying. You also get a glimpse at a really elegant set of experiments that Gregor Mendel did back in the 1800s with his pea plants. He was a monk in a monastery, and he grew peas. And he was interested in how the traits in the pea plants, were passed along into the next generation. So he grew peas and he crossed peas, and he looked at the offspring, and he counted nearly 30,000 pea offspring and came up with ideas about genetics. There wasn't even genetics then. All he could explain was there would be 2 different traits in an individual for 2 different copies of a trait in an individual for a particular trait, and you inherited one from your mother and one from your father, and that there were dominant and recessive traits. Dominant traits were always present. You could always see them. Recessive traits could be hidden unless there were 2 copies of a recessive trait. Now, you have heard of that terminology. He came up with this back in the 1800s, and he did that through examining almost 30,000 pea plants, which is amazing. Simple yet elegant, perfect type of scientific investigation. You're going to do a revision of your rough draft this week. Use your rubric to guide your work. look back at any grading that I've done to make sure that everything falls in line correctly and that you correct stuff as you go. So because I continually regrade your introduction and your question and all of that stuff. So make sure you go back and fix things that need to be fixed. There are a bunch of cute little wood ducks at the bottom of my page. Aren't they so cute? And the tip of the week is to use the feedback for me to improve your work. I mean, that's one reason I'm grading, to help you get better, to help you see where you need some help. And if there are any questions ever about the feedback, please let me know. I don't mind if you ask questions about that. I'm here to help you get better at what you're doing. So please let me know. m.sigmon@snhu.edu. I'm here for you. Let me know if you need anything this week. With that being said, I hope that you have a wonderful week.